Okay, alpha and beta are in the fourth quadrant. So it's going to be pretty easy to figure out what the cosine of alpha is and what the sine of beta is. So I'm going to write this down. So the sine of beta, we need to figure that out. And we need to figure the cosine of alpha. All right, so what do we know about this? In the fourth quadrant, the sine is going to be negative. And in the fourth quadrant, the cosine is going to be positive. All right? So let's figure this out. And we got the Pythagorean theorem to do so. So I'm going to look at this one first. So it's going to be 13 squared equals 5 squared plus x squared. All right, what do you get here? 169. This is 25 x squared. And then you get 144 equals x squared. So the x is going to be plus or minus 12. Now here's the deal, though. This is for the angle alpha. Oh, you know what? I forgot to write something down over here. I know the denominators in each of these cases. For beta, it's 5. And for alpha, it's 13. Sorry about that. I should have written that down before. But anyway, let's look at the, we're on the alpha now. I know the cosine's going to be plus 12 then. Okay, I'll put this over here. Well, let me get my eraser out because I don't really need that plus sign there. Get rid of that. Let's do the other one. And that's going to be 5 squared equals, well, that's going to be x now, so that's 9, or 3 squared, I'm sorry, plus the y squared. And what do you get there? 25 minus 9, which is 16, equals y squared, and the y is plus or minus 4. What do I know about it? It's in the fourth quadrant. The ordinate's going to be negative. I know that much. All right, let's see what the questions are. I'll erase this business over here. I got what I need. I do want to emphasize it's written down for me. So I know the sine of alpha. I know the sine of beta now. The cosine of alpha, 12/13, and the cosine of beta is 3/5. So I know all that information. And what do they want to get from me? They want to get cosine alpha minus beta. So what's that? I'm sorry, sine of alpha minus beta. So it's going to be sine of alpha, cosine of beta, minus sine beta, cosine alpha. Let's write this down. There's 4 things to write down. And let's do one at a time. So the sine of alpha is minus 5/13. The cosine of beta is 3/5. Let's see, the sine of beta is minus 4/5. And the cosine of alpha is 12/13. Well, I get a common number 65. I get minus 15. And let's say it's going to be plus 48. All right, let's just do the arithmetic over there. Common number is 65. And what do you get there? 43/33. Let's look at the key, make sure we got that answer. All right, it's going to be another question over here. Let's see what the next one is going to be. Cosine of alpha minus beta. What's that going to be? Cosine alpha, cosine beta, plus sine alpha, sine beta. Well, there's 4 things to write down. No need to memorize. Cosine of alpha, let's go back up here. Cosine of alpha is 12/13. The cosine of beta, scroll back up, is 3/5. The sine of alpha, minus 5/13. And the sine of beta is minus 4/5. Again, common denominator 65. We're going to get 36 plus 20, which is 56 over 65. Let's get a red pen out, see how we did. We're doing okay. Now the tangent, well, let's take a look at that. That should be relatively simple to do. And the reason for that is going to be equal to the sine of alpha minus beta over the cosine of alpha minus beta. Well, we just did the cosine of alpha minus beta, and that's 56 over 65. And the sine of alpha minus beta was also done, and that was 33 over 65. What do you get there? 33 over 56. Let's put a box in that, get the red pen out, check it. Okay? Okay, this one's a little more difficult, and it wants the alpha over 2. So before I do anything, I got to figure out what quadrant it's in. And the reason why we have a formula for this, the sine of alpha over 2, and that's going to be equal to plus or minus, and this is the issue, by the way, the root of 1 minus cosine alpha over 2, all right? So before I do anything, I want to just go back and remind you that these angles are in the fourth quadrant. So alpha is between 270 and 360 degrees. So alpha over 2 is going to be between 180 and 135. That means it's in the second quadrant. So the sine is going to be positive in the second quadrant. So what do I know about this over here? I know it's going to be a plus sign now. So let's write this down. So the sine of alpha over 2 is going to be plus the root, whoops, sorry about that, is equal to plus the root of 1 minus cosine alpha. Again, cosine alpha, we spent some time getting that. That's 12/13. I'm going to multiply top and bottom by 13. And what do you get over there? You get 13 minus 12 on top, which is 1 over 26, which is going to give you, well, it's going to give you 1 over the root of 26. All right? I'll put a box in that. If you want to rationalize the denominator, you can. There's no need to, though. Okay, let's do the cosine of alpha over 2. And again, this is trouble. And the main trouble is because the cosine of alpha over 2 could be plus or minus 1 plus cosine of alpha over 2. Let's take a look at it again. And we know that the alpha over 2 is in the second quadrant. We just did it. So we know the cosine is going to be a negative number. And what's going to be equal to minus the root 1 plus the cosine of alpha. And we just looked that up before. It's 12/13. Multiply top and bottom by 13, the fraction, or the radicand. What do you get there? 13 plus 12, which is 25, over 26. What does this give me? Minus 5 over root 26. Let's put a box on it, commit to it, and let's look at the k. See how we did. It's right over here. Let's see if there's another question, and there is. They asked for this one over here. All right? How do I do that? Sine. Let me get my eraser out. It's going to be the sine of alpha over 2 divided by the cosine of alpha over 2. We just did both of those, and let's write it down. And what do you get? Well, you get the sine is 1 over root 26, and the cosine was minus 5 over root 26. Well, that's pretty simple to do. It's just simply minus 1/5. Let's look at the key, see how we did. Whoops. And we got it. Thank you.